So, good morning, everyone, and welcome to the lecture. As we have finished Newton laws of motion in the last class, and in today's class, we will start with the next topic, small one, friction. Any idea what is meant by friction? Any idea what do you mean by friction? Hmm? What is meant by friction? Yes, anyone? What do you mean by friction? Anyone? No idea. No idea. Anyone? Say yes or no. If you may have idea, you may not have idea, but at least say yes or no. Do we have any idea about friction? Do you know what is friction? Yes or no? It's not a very complicated question. It's a very simple one. Do we know what is friction? Someone asked me, sir, do you know quantum physics? I say, no, I don't know. As simple as that. Similarly, I am asking you whether you know what is friction. Yes?
The force is parallel to the surface of contact is called frictional force.
The force which is parallel to the contact surface is known as frictional force. Okay, that is good. So you have read it from the notes that I had given, and then you are giving me the answer. I was asking your answer. I was not asking what I had given. Okay. What do you mean by friction? Now, whenever two bodies are kept in contact, what happens? Whenever two bodies are kept in contact, what happens? They exert forces on each other. Yes or no? Whenever two bodies are kept in contact, they exert forces on each other. That force we already know is known as the contact force. Whenever two bodies are kept in contact, they exert forces on each other. That is known as the contact force. I already shown you the diagram. Now, if the body, let us say, is moving in this direction, but this body is kept on a surface. These two bodies, the surface and the body, exert forces on each other. That force is known as the contact force or the reaction force, R. Now, this contact force or reaction force can be resolved into two components. One of the component is perpendicular to the two bodies, which we have already seen is known as the normal force. The other component is one more component which is parallel to the two surfaces. This component is known as friction. So what is friction? Friction is the parallel component of contact force. So you can call this friction as the parallel component of the contact force. Whenever two bodies are kept in contact, they exert forces on each other. The parallel component of this contact force is known as friction. What is the work of this friction? What does friction do? Yes. What does friction do? What is the work of friction? What does friction do? No idea? Have you ever heard the term friction ever in your life? Yes. So what does friction do? You would have also heard, since you've heard the word friction, you would have heard what does friction do. No, you only heard the word and don't know the meaning. Okay, the work of this friction is the work of this friction is to oppose. Let me write it this way. Friction opposes what? Friction opposes what? Never heard it? You already dealt with friction in your lower standards, yeah. You can't be so. Yes, friction opposes what? Must have heard this. It's not about physics.
Relative motion.
You would have heard it, right? Why you are not able to recollect it? You have heard it. I know you have heard it. You are in 11th standard. You would have heard what is friction. Yes, what does friction do? Friction opposes relative motion. That is the most important term. That friction opposes relative motion. You might have heard in your lower standard that friction opposes motion. Friction does not oppose motion. It only opposes relative motion, or sometimes there is no relative motion, but there is a tendency of relative motion. So friction opposes relative motion or the tendency of relative motion. That is what friction does. It opposes relative motion or the tendency of relative motion. These are the two terms that you must remember about friction. What you must also remember, that friction does not oppose motion itself. So if someone says friction opposes motion, you must say no, friction does not oppose motion. In fact, it is because of friction motion is possible. Friction does not oppose motion. I'm writing on this pad because of friction between the pen and the pad. You are writing on the book because of the friction between the pen and the pages of the book. If there is no friction, well, you will not be able to sit on the chair or the table that you're sitting because you will slip. If there is no friction on ground, your wheels of the car will only turn, but the car will not move forward. Car only moves forward because of friction between the road, friction between the road and the wheels of the car. So it's wrong to say that friction opposes motion, but yeah, friction opposes something. And what is that something? That something is relative motion between the two bodies. It opposes relative motion between the two bodies, not motion. So remember that friction only opposes relative motion or the tendency of relative motion. Sometimes there may not be any motion, but there may be a chance of a motion happening. So friction will oppose even that chance of relative motion happening. Do we understand this? Yes or no? Yes or no? We understand this? Now, whenever we talk about friction, friction comes from contact force. You can see the contact force. It is the parallel component of this contact force. So the next heading that we are going to write is known as the angle of friction. Angle of friction is the next heading that we'll write. Now, what do you mean by this angle of friction? What do we mean by this angle of friction? Again, take you back to the diagram that we had drawn. This friction comes from the contact force. The contact force may not be perpendicular. The contact force can be going at any angle. This angle between the contact force and the normal reaction, the angle between the contact force and the reaction force, or R, or contact force and normal force R, this angle theta, is known as your angle of friction. So angle of friction is the angle which the contact force makes with the normal reaction force. So I can write this angle tan theta of this angle would be F divided by N, where F is your frictional force and N is your normal reaction force. Sometimes you may be asked to find out the value of this reaction force. How will you find out this value of this reaction force? You must remember that this reaction force has two components. One is the normal reaction force, the green one. One is the friction, which is F. Now, these are components of the reaction force. So from vector addition, we can find out the value of this reaction force or contact force. The value of R, the reaction force or the contact force, will be equal to F square plus N square. So these are the two things that you must remember about the contact force. One is the angle of friction. Angle of friction is the angle that the contact force makes with the normal, this diagram. The value of this reaction force is under root of F square plus N square. I'll give you 2 minutes to note this down.
Completed, sir.
Everyone completed? Boys? Have you noted it down, beta? No response. I'll hope that they have noted it down. Anyways, let us move ahead. Now, whenever we talk about friction, this friction can be thought of as two types. What are the two types of friction? The
Static
first,
friction, kinetic.
see, you know the types of friction, but you did not tell me what is friction. It is not good. I know that you know it, but you did not tell me. Anyways, good. The first type of friction, you can call it as kinetic friction. The second type of friction, you can call it as static friction. What is the difference between the two? Any idea what is the difference between the two? Kinetic friction comes when there is relative motion between the two bodies. Whenever there is relative motion between the two bodies, then this comes and it opposes this relative motion between the two bodies. So it will come when one body is slipping over the other body. There is a relative motion between the two bodies. Then this kinetic friction comes into the picture. What about your static friction? The static friction comes when there is no relative motion, no RM, no relative motion, but there is a tendency of relative motion. So even though there is no relative motion, but there is a tendency that the motion can happen. If there is a tendency that the motion can happen, then this static friction will come. Now, the best way to understand this would be with a diagram. So let me draw a diagram here. If you have a block of, let us say, mass m, and it is moving with a velocity v, it is moving with a velocity v. In this case, whatever, in this case, the friction between the block and the body will be Fk. That means it would be kinetic in nature. F standing for friction, K standing for kinetic. So whenever there is a motion between the two bodies, whenever there is a relative motion between the two bodies, the friction that is going to come will be kinetic in nature. Do we understand this? You have disappeared from the screen. Is everyone there? Do we understand what is happening in the class? Or I have lost you somewhere? Your universe is vast. Okay, not a problem. Your mic is not working, but my mic is working, and I hope I am visible and audible both at the same time. Okay, I was talking about kinetic friction, and kinetic friction happens when there is a relative motion between the two bodies, and it will oppose this relative motion between the two bodies. I hope the point is clear, and I have shown you the diagram also. If there is a body of mass m moving, there is a body of mass m which is moving on this block, on this surface. The block of mass m is moving on this surface. The friction that happens between the block and the surface is kinetic. But sometimes there may not be any motion, but there is a tendency of motion. Now, how can I make you understand that? Don't worry, we will be doing a lot of examples on this. Right now, a simple diagram may be good enough to make you understand this. For example, there could be an inclined plane like this, plane which is inclined at an angle, and I have kept a body on this inclined plane. Now, it's not necessary that this body is moving, because it can just stay in that place. Why it can stay in that place? Because there is friction. So this body which is on the inclined plane is at rest. The type of friction between this body and the surface would be Fs. S standing for static, F standing for friction. Whenever there is no relative motion, but there is a tendency of relative motion. What do we see here? Even though this block is not moving, it wants to move in the downward direction. So it has a tendency to move in the downward direction. It wants to move in the downward direction. It has a tendency to go down, but it is not going down. It wants to go down. There is no relative motion. The friction that comes in this case is known as is known as static friction. Do we understand this? Yes or no? Okay, I'll give you 2 minutes to note it down with the diagram and all. Once you are done, please let me know with your hands or whatever. If you can say, that would be good.
Completed, sir.
Okay. What about the boys? Are we done? Anyone done this? I hope yes. Oh, no. Great. I think we have done. So, what we have to do now is to study these two types of frictions, and we will do both the frictions separately. And we will start with the simpler one. Which one is the simpler one? The friction which is happening when the body is at rest, is that the simpler one? Or the friction in which the body, there is a relative motion, this one is simpler. Which one is simpler? The rest one or the moving one? Well, both are simple, but just for the sake of continuity, I will move on with the first type of friction, and the first type of friction is known as kinetic friction. And we will represent it by Fk. K standing for kinetic. Now, first of all, you have to understand when does this kinetic friction comes. Again, you must understand that this is the parallel component of what? So that we don't forget it. This is a parallel component of what? Parallel component of what? This is the parallel component of the contact forces. This is the parallel component of contact force. When does this kinetic friction comes into the picture? It comes into the picture when there is relative motion. When there is relative motion between two bodies or a body and a surface. What is the work of this kinetic friction? What does it do? So it opposes the relative motion. Now, whenever we talk about kinetic friction, friction is a force. Any force will have magnitude as well as direction. So whenever we talk about kinetic friction, this kinetic friction must have two things. What are the two things that this kinetic friction must have? What are the two things this kinetic friction must have? It is a force. So what are the two things it must have? What are the two things it must have? Kinetic friction is a force. Force is a vector. So what are the two things it must have? No idea? Okay. It must have magnitude. It must have direction. Any vector must have magnitude and any vector must have direction. What is the magnitude of this kinetic friction? The magnitude of this kinetic friction is always fixed, and that is equal to mu k multiplied by n. The magnitude of this kinetic friction is fixed, and that is equal to mu k multiplied by n. The direction of kinetic friction would be such that it opposes the relative motion. So, if I talk about the magnitude of kinetic friction, I can write this formula: Fk will be equal to mu k multiplied by n. That becomes the formula for finding out the magnitude of kinetic friction. What is n here? Anyone? What is n here?
Normal reaction.
N
Normal
is
reaction.
the normal reaction, very correct. N is the normal reaction force. Normal reaction force. What about this mu? What about this mu? Mu is a constant.
Coefficient of kinetic friction.
Yes, and this constant is known as coefficient. Coefficient of what? Coefficient of kinetic friction. This mu is a constant and it is known as coefficient of kinetic friction. So, mu k, which is the coefficient of kinetic friction, it depends on the two surfaces which are in contact. Mu, it depends on the surfaces which are in contact. If you change the surfaces, then only mu will change. If you put some oil or lubricant, then the value of mu will change. Do we understand this? Mu k does not depend on area of contact. Do we understand this? If I have a body, this is the surface, and this is the body. If I keep it like this, or I keep it like this, the value of mu k does not change unless and until the surface changes. Here it will change because this surface is different compared to this one. So if I keep it like this, friction would be different. If I keep it like this, friction would be different. But if the surface is same, the value of mu does not change. This is same surface from all sides. So I keep it like this, or 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 I keep it like this. The value of mu k does not change. Do we understand this? Similarly, the same thing can be said about the value of Fk. Fk does not depend on area of contact. If the surface is same, I keep it like this, 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 I keep it like this. If the surface is same, the value of friction does not change, because friction only depends on two things: It depends on mu k. It depends on n. If you don't change the value of mu k or you don't change the value of n, friction remains constant. Do we understand this? So, as an example, if you have a body, the body is kept like this, or the body is kept in the lying position, the value of friction will remain same. Do we understand this? It cannot change just by putting the body down or putting the body up, unless and until you change the surface. For this body, it is going to make a difference. If I keep it like this, surface is different, friction would be different. This side is slightly rough. But if I keep it from the screen side, which is very smooth, the value of friction is different. It has not changed because of the surface changing. It has not changed because I have kept it in a different way. It only changes because the surface has changed. Do we understand this? It only changes because of that. So friction does not depend on the area of contact. It only depends on the surface which is in contact. Do we understand this? This has gone above our head saying bye bye. Enough for today. Have you noted it down? Okay. Now comes the next point, direction of friction. Direction of Fk. Direction of kinetic friction. How will be the direction of kinetic friction? The direction of kinetic friction is such that it opposes the relative motion. The direction of kinetic friction would be such that it will oppose the relative motion between the two bodies. On the two bodies, kinetic friction is an action-reaction force. So kinetic friction would act in opposite direction for both bodies. Do we understand this? For both bodies, it will act in opposite direction. What do I mean by this? For example, if I have a simple case, if I have a body of mass m moving like this v, now this v is the velocity of body with respect to ground, and the lower one is ground. So ground is not moving. Do you understand this? Ground is not moving. This body is moving on the ground. So there is a relative motion between the body and the ground. Do we understand this? This is the body and this is the ground. Ground is not moving. Body is moving on the ground. So there is relative motion between the body and the ground. Do we understand this? Okay. Now, if I talk about frictional force, what type of frictional force will be acting here? Since there is relative motion, the type of frictional force that would be acting would be kinetic friction. Yes or no? Now, can you tell me with common sense, it has got nothing to do with physics, what will be the direction of kinetic friction on this body, this block of mass m? What will be the direction of kinetic friction? This body is moving forward. So what will be the direction? Will it be in the forward direction? Will it be in the backward direction, upward direction, or downward direction? Which one? So the direction of kinetic friction for this body would be in the backward direction. Do we understand this? This is the kinetic friction applied by the ground on the body, but body will also apply kinetic friction on the ground. What will be the direction of kinetic friction applied by body on the ground? The direction of kinetic friction applied by body on the ground would be in the forward direction. Do we understand this? And that is what I mean by opposite direction. You look at these two forces, they are in the opposite direction because this kinetic friction is an action reaction type of force. Whatever be the direction of friction applied by one body on the second body will apply the same frictional force, same magnitude, but opposite in direction. Do we understand this, or this has gone above? Let's sing bye bye. We are going. Don't worry about it. Do you understand this? One more thing that you should remember about kinetic friction, the direction of kinetic friction is not opposite to the applied force. But it will be opposite only to the direction of relative motion. Do we understand this? The direction of kinetic friction or any friction, it has got nothing to do with which direction you are applying force. It has got nothing to do with the direction of force. It only goes in the direction which is opposite to the direction of relative motion. Do we understand this? The best example in this case would be this one. So, as you can see here, there is a body of 1 kg moving with a velocity of 5 meter per second in the right direction. A force F is applied in the left direction or backward direction. Now, tell me, first case, first thing, what type of friction will act between the body and the ground? What will be the type of friction between the body and the ground? The friction would be kinetic because there is a relative motion. Now, the second thing is, what will be the direction of kinetic friction here? Will it be in the forward direction or will it be in the backward direction? Remember, the force is in the backward direction, but the body is moving in the forward direction. It has got nothing to do with force. The direction of kinetic friction would be in the backward direction. It has got nothing to do with force. Do we understand this? Yes or no? I'll give you 1 minute to note this down. Have you noted it down?
Completed, sir.
Okay. Then there is a small question here. You have to tell me the direction of kinetic friction between the two bodies. Remember, this is a rough surface, so ground is rough. These two bodies are also rough. You have to tell me what will be the direction of friction on all the bodies and who is applying that frictional force. You have 2 minutes to do this. Got the answer? Both the surfaces are rough. Have you got the answer? Okay, so how are you supposed to do this? You look at the body B. Body B is in contact with ground. With respect to ground, body B is moving forward. So the ground will apply frictional force in the backward direction. Let me call this as Fg. This is the friction force applied by ground on the body B. Now I look at body A and body B. Remember, friction opposes motion. No, friction does not oppose motion. Friction opposes relative motion. With respect to body B or with respect to body A, how is the other body moving? If I become A, how is the body B looking to me like? Where is body B moving with respect to body A? Body B is moving in the forward direction with respect to body A, yes or no? Therefore, body B will apply frictional force in the opposite direction. This is the frictional force between the two bodies. I am calling it FB. Now, since you know that body A is applying frictional force in the backward direction on body B will apply frictional force in the forward direction. You can also find it out from the relative motion. So these are the direction of friction in the two cases. Do we understand this? Okay, great. Note it down, please. Once you are done, please let me know.
Completed, sir.
Everyone done?
Yes, sir.
Okay. Then one more last thing. You can also find the angle of friction. Now, in this case, what is the angle of friction? Now, do you remember that diagram for angle of friction? Do you remember that diagram? We'll have to again draw that diagram. Angle of friction in this case. Remember, this was the angle of friction. And I told you that angle of friction tan theta is equal to F divided by N. Yes or no? Now, in case of kinetic friction, the value of kinetic friction is mu k into N divided by N. N say N will get cancelled and you will get tan theta equal to mu k. Tan theta will become equal to mu k. Do we understand this? So angle of friction tan theta is equal to mu k. Everyone understands this? The next thing is the value of R. The reaction force was F square plus N square. You can write F as mu k into N ka whole square plus N square. And you have to take the root of this. So N will come out and it will be root of mu k square plus 1. That would be the value of your reaction force. So there are two things. They might not ask you in NEET, but since you know, you can write out these two things. I'll give you 1 minute to notice down. Have you noted it down, everyone?
Sir.
This is the first question. I hope you can understand what do I mean by this. This is a block moving with a velocity of 10 meter per second on a rough ground. You have to tell me what type of friction will happen between the body and the road. As you can see, the body is moving, so the friction is kinetic. You have to tell me the magnitude. You have to tell me the direction. You have to find out the value of normal reaction. You have to find out the value of theta. What is theta here? What is theta? What is theta? What is this theta I've written? You don't know? So you find it out and you know. What is theta? You don't know?
Tan theta equals to mu k kada.
And you have to find out the value of R. So you have 2 minutes to do it.
Tan theta equals to 0.2. 0.2.
Yes, anyone with any answer? Did you get any answer? Bacho? Say something. Did you get any answer, beta? Okay, then we'll solve. I'll give it as a homework. Solve it, and we will see the solution in the next class. Okay, you'll have to try. You already know how to do it. You already know now how to do it. Yes or no? So do it in the next class. Give me the answer in the next class. I'll see you tomorrow, and I want answers from all of you. Everyone you know how to find out the value of n. Yes or no? Find out the values for all these four quantities and let me know in the next class. Take care. God bless you all. Bye bye.
Bye, sir.